everyone, welcome to APS Deep Academy and this is your mentor Swati Joshi. In this class, we will study about LC choke input filter, pi filter, T filter, and we also discuss few differences between the filters. This is the circuit diagram of LC filter. LC filters are also considered as choke input filter. So this is nothing but choke input filter. Now here we can see that one inductor is connected with the capacitor and capacitor is connected in parallel with the load resistor RL. We know that capacitive reactance or XC is nothing but 1 upon 2 pi FC, and for DC component frequency is 0. So XC will become 1 upon 0 in case of DC component and 1 upon 0 is considered as infinity. So for DC component, capacitive filter or capacitor is work as a blocking bias because it will provide infinite resistance or work as an open circuit when DC components flow through it. Similarly, in case of inductance, we know that XL is nothing but 2 pi FL. So, for DC component, F is again 0, so XL will become 0. It means it will provide the low resistance, almost 0 resistance in case of DC, and when F has some value or in AC signal F has some value, let 50 Hertz is a value, so we will put the 50 Hertz and take the XL according to this. But at maximum level, this frequency can be increased till infinite. At maximum level, if it will increase till infinite, so at that time XL will become infinite. So in case of AC signal, we consider that this XL or the resistance or the impedance over the inductor coil is nothing but infinite in case of AC signal. So it is blocking the AC signals here. So inductor is our AC blocker, whereas the capacitor is our DC blocker. So it blocks the DC component and inductor block the AC component. One more property of inductor is that it is very prone to change in current or voltages. So if the voltage or the current change in a particular manner, the inductor will produce a back EMF to counter that and maintain a particular level. See, if suppose this is the input, this is the full wave rectified input, what is happening? This is changing from Vmax to 0. It is going like that. But what happened with the effect of inductive property, this will maintain at a particular level because inductor will provide a back EMF to counter this. So it will not go down, but it will maintain at a particular level. Similarly, again the waveform come, it will maintain at a particular level. So inductive property is first, it is blocking the AC component. Second one, it is managing the change of current or voltages in a particular manner by giving the extra charge to the lower potential and taking the extra charge from the higher potential. So if it is taking the charge from the higher potential, then the inductor, we can say it is in charging mode or it is storing the charge in the term of magnetic field. And when the input is low or the input is going down, then this inductor releasing the energy and giving to that in the form of back EMF, which is produced in the inductor coil. So these are the two properties of inductor. Similarly, for capacitor, what we have, capacitor like this. In this case, if this is the higher peak or signal is increasing, then we see capacitor voltage is smaller than Vmax. At this time, capacitor will charge, and when we see this capacitor voltage is greater than Vmax, then at this time, because Vmax is lowering down, so this capacitor voltage is greater than Vn. So at this time, it will charge. So when capacitor is charging, the waveform is like that, but after that the waveform is going down, but due to the discharge of the capacitor, it will maintain at a particular level. So this is the output waveform when we use a capacitor as a filter. This is maintained in that manner. Clear? Now we will see the effect of both L and C here. What is happening with both L and C? See, first, if input signal is going and L is first what is doing? Passing the DC signal and blocking the AC one. It is providing the open circuitry for the AC signal. Now what is happening? If few AC signal left, then this capacitor is working and making those AC signal to directly go into ground. Why so? Because for AC circuit, this AC signals, AC components, this capacitor circuit is working as a shunt here. So all AC components which were left with the inductor coil are going to ground. So only the DC component which were present in the input are passing towards the output. So at output, what we are getting? We are getting more refined output waveform, which we were earlier getting in L and C filters. This is more refined in case of this choke filter or LC filter. Now this is the circuit for pi filter. Now why pi filter? Pi because this structure, two capacitor and inductor, this structure making like pi like structure. So this is considered as pi filter. Now what is happening in pi filter? Similarly like C and L, the properties will follow. Capacitor will block the DC and inductor will block the AC component. So what will happen at first cycle when AC component are coming? So it will flowing towards this capacitor, and this capacitor is making it ground because it is connected in a short circuit manner, providing the zero resistance or impedance to AC components. So AC components are directly flowing in this path and it will be grounded. And DC components are flowing towards this inductor because AC components are blocked by this inductor. So only DC components are providing, DC components are flowing toward the inductor. Then whatever the left component, already this capacitor has cleansed the AC component and this inductor also cleansed the AC component. But again this capacitor making all those AC components to going to ground and providing the clear path for the DC. So whatever the DC voltage, whatever the voltage in this node is directly transferred, whatever the voltage in the node is directly transferred to the load resistor RL. So very profound DC we are getting here, which we consider as steady state DC. Okay, steady DC. Now in this case, the filtration is even more than RN, even more than LNC filter. Okay. Now one filter is T filter. So T filter, what happened? In T filter, two inductor coils are connected with the parallel. See, this is our T filter. I will make here two inductive coil are connected with the capacitor. So this is our T filter. Clear? This is our T filter. So in T filter, what will happen? The structure of T-like structure is making. So this is considered as T filter. And here we will get the output. Okay, this is load resistance RL. Now this is the structure of a T filter. Two inductor coils are connected with the capacitive filter. Same working happen. First, AC component are blocked, so only DC will pass. Whatever the DC component will left, whatever the AC component will left will pass through this capacitor and it will be grounded. And only the DC component will flow towards this inductor. And this DC component, whatever the AC component still left after filtration, it will still further, removed by this inductor coil. And at RL, what we are getting? We are getting the pure DC, which is not pulsating but a steady state DC. So these are the filter circuit which we use with our rectifier circuit. So for now, this is enough for today. Thanks for watching and please subscribe the channel and like and share also with the needy one. Thank you so much.